All right. Three identical masses are attached to the ends of a light strings and the other end which are connected together as shown in the figure 1. So there are three identical masses. Okay. So mass M, mass M, mass M. And they are attached to the ends of the light string and the other end which are connected together, it's fixed somewhere. Length of each string is 3m. Okay. Three masses are dropped through three holes in a table and the system is allowed to reach in equilibrium. So there is a table with three holes at A, B, C and distances are 1, 1 and 2 root 3 and these masses are allowed to fall from the table. The total length of the string lying on the table is A plus root B by 3, then A plus B is. So first of all, this situation you have to analyze what is actually given the situation. That is the first part, analysis, and then the second part is how to solve the question. So you can just take a pause and try this question if you want, and then you can verify the answer. And if you are not able to solve, you can look at the analysis so that you learn that where you went wrong, why you could not think. If you could not solve it, then it's more important to analyze why you could not solve it, okay, rather than what the solution is. Okay, so I will just start the analysis first. Okay, so now see, this is something like this. A table is kept. I am drawing a 3D figure for better understanding. Control Z. Okay, so this is a table kind of structure, and there are three holes in the table. So these are the three holes, probably like this, and the masses are falling through this hole. So one mass is like this, then string must be going like this, then other mass is hanging from here and last mass is hanging from this side. So these are the three masses which are hanging and this is the knot, the knot we have tied it here. So these masses, that's given in the question. If you read, that is what given in the question. These masses are dropped through three holes in a table and the system is allowed to reach in equilibrium. Total length of string lying on the table is. So we have to find the total length of the string which is lying on the table. This length and this length. Yeah. So this is what we have to find. So this is the situation. All right. Now how to go about it? So in question like these, generally they will not make it very complicated. They will give data is similar, same kind of simple data. So here the three masses are identical. So if the system is in equilibrium, tension is equal to mg. So now if you look at this part, the part which is lying on the table, if you look at this part, for every part equilibrium, for equilibrium this is mg and this is tension which is upward. So for equilibrium, tension is equal to mg in each part. So tension in the string is mg. So that means if all the three forces are same, if all the three forces are same and net force should be 0, then this is what we can conclude, that for all the three tensions the angle must be 120 degree, because the tension is same, because all the masses are same. So T is equal to mg, T is equal to mg, T is equal to mg. And for that to remain in equilibrium, this is the top view of table. So all the strings must be aligned at 120 degree to each other. So then only the net force will become 0. Identical forces are there, three forces are there, so 360 by 3 is 120. So these strings must be aligned at 120 degree with respect to each other. Now if you look in this triangle, only twist here is, now if you look in this triangle, this is not an equilateral triangle. Side is 1 meter, 1 meter, and this side is equal to 2 by root 3 meter. So now how to solve it? I will just take a new page. Okay. So 1, 1, 2 root 3. So now I will draw a triangle and this is the only calculation part that you have to do. 1, 1 and this was 2 root 3. So at least this is an isosceles triangle. Now from the symmetry of it, we can figure it out that this string has to be at 120, 120, 120. This is not an equilateral triangle. So that means the junction point, the knot that you are seeing here, will not lie at the centroid, right? Because this triangle is not an equilateral triangle. But at least this is an isosceles triangle. So we can say, all right, it's not at the centroid. Maybe it's somewhere here, who knows, but it will be on this line, the vertical line, the line bisecting the line, because at least it is an isosceles triangle. So that knot is not at the centroid, but it is somewhere on this line only. This is the knot and this is the string, length of this string like this. So these three strings are passing like this and it is tied here, and these angles are 120, 120 and 120. Why I have not drawn this at the centroid? Because this triangle is not equilateral triangle. This is an isosceles. So now we have to find the length of the string on the table. So we have to find the length of the pink line. Now we will just use geometry and get the answer quickly. This angle is 120 and this is symmetric. So this angle is 60 degree. This is 90 degree. This is 30 degree. Okay. Now this is, let's say, P. This junction is Q and this is R. So we can find the length of PQ easily. We can use what result? Cos 30. Cos 30 is equal to base, which is 1 by root 3. 2 by root 3 is the full length. So half is 1 by root 3, other half is 1 by root 3. So cos 30 is equal to base upon hypotenuse. Hypotenuse is PQ. Cos 30 is root 3 by 2. So PQ is equal to 2 divided by 3, right? Root 3 into root 3 will become 3. So PQ is equal to 2 by root 3. Similarly, RQ is also 2 by root 3. Okay, same logic. RQ is also equal to 2 by 3. PQ is also 2 by 3. Now about Q and S. So we have to find the length of Q and S. So this also again triangle property. So let's take triangle PRS. Triangle PRS. Now it's just geometry. Triangle PRS. We have to calculate this angle. So let's say this angle is theta. Okay. So tan theta is equal to, or maybe sine theta we can use, or why use theta and all? We can use our Pythagoras theorem also. In PRS, PS square is equal to PR square plus SR square. So PS is equal to 1, PR is equal to 1 by root 3. So 1 by 3 plus SR square. So SR is equal to 1 minus 1 by 3 is 2 by 3. So root 2 by root 3. So this is your SR, S to R. This full length we have calculated from S to R. Now we have to calculate SQ. So what is the length of QR? QR also you can find here only. I will do it. QR. Let's take triangle PRQ. Okay. So we have to find QR. So we can use cos 60. Cos 60 is equal to base upon hypotenuse, or let's take tan 60. It's better to take tan 60. Tan 60 is equal to perpendicular, which is 1 by root 3 divided by base, which is QR. Tan 60 is equal to root 3. So QR is equal to 1 by 3. Nice. So now QR is 1 by 3. SR full length is root 2 by root 3. So what about SQ? SQ is equal to SR minus QR. So SQ is equal to SR is root 2 by root 3 minus 1 by 3. So take 3 as the LCM. So root 2 into root 3 minus 1. So this is SQ. So now we have our final answer. Length of this string on the table. Length of this string on table is, this red length is, first of all, PQ is equal to 2 by 3. QR is also 2 by 3. So length on the table is 2 by 3 plus 2 by 3 plus SQ. So SQ is equal to root 2 root 3 root 6 basically minus 1 by 3. So length of the string on table 3 is the LCM. 2 plus 2 4, 4 minus 1 is 3. So 3 plus root 2 root 3. Plus root 2 root 3. Now 3 will get cancelled. So this will be 1 plus root 2 by root 3. And in the question it was a plus b by root 3. And we have got 1 plus root 2 by root 3. So that means a is equal to 1, b is equal to 2. So a plus b is equal to 3, which is your answer. So obviously this is a difficult problem, JEE tough JEE advanced kind of problem. This has not come in JEE advanced, but this is kind of a JEE advanced problem, which is a tough JEE advanced problem. Probably Olympiad problem also you can classify it. So one thing was analyzing the situation. I will just tell you, one thing was analyzing the situation. This was your step 1. So every step teaches you something. This is your step 2, where we should know that if it is symmetric, then if the forces are symmetric and if it is in equilibrium, the angle must be equal. So 120, 120, 120, this is your step 2. And this is your step 3, where you have used symmetry and bit of geometry. So after this there is only calculation. First we calculated the length of PQ, then we calculated the length of QR, and then we calculated the length of SQ. So PQ, QR and SQ, these are the lengths of the string. We added it and got the answer. So that would be it. I guess someone is at the door. Bye bye.